Okay, we're going to look at problems 6 through 10 on this video that reviews the multiple choice for the integrated 3 midterm. Okay, for this one, we're going to choose all of the factors of 5x squared minus 28x minus 12. So we have a couple different ways we can work with it. So one thing to watch out for is difference between a factor and a term. 5x squared is a term, that's not a factor, so that's a distractor. Now you also have kind of hints in terms of your answers to kind of help you thinking about how it factors. So that does help a little bit. So you can kind of take advantage of what the answers are to help you with the process. Okay, the fastest way is to simply kind of doing a little guess and check and thinking about our numbers. Okay, so to get 5x squared, I have 5x times x. That's the only way of getting 5x squared. Then, to get negative 12, the last two have to multiply to give me negative 12. Well, I could do, and I'm just going to ignore the negative for now. To get 12, I got 1 times 12. I could do 2 times 6, or I could do 3 times 4. Well, even if I look at my answers, the numbers I'm seeing are 2s and 6s. So let's say you thought you had to have 6 here and 2 here. Well, what I'm going to do, and I haven't bothered putting in signs yet because I don't know which one I'm going to be using. I know one's positive, one's negative. And I could always play it safe, because like, well, I could see a 5x plus 6. Let's go and give that a try and see if that works. Well, I've got 6x minus 10x. Oh, that gives me negative 4x. So that didn't work. The other choice, I can erase this. And let's say I put 2 here and a 6 there. Okay, now, and this is why we work in pencil, so we can erase. We have 2x and negative 30x. That's negative 28x. Okay, that's the one I want. So I know for this one, my answers are 5x plus 2 and x minus 6. Okay, here's another method. You could use generic rectangles. So if I just go and I build out a rectangle, and this is particularly important because when you do the free response, you're not going to have multiple choice where it's going to give you the potential answers. So let's make a rectangle. 5x squared goes in this box. The negative 12 goes here. When I multiply these two together, I get negative 60x squared. When I multiply these two together, they also have to give me negative 60x squared. So now, when I add the two together, I need two numbers that add to give me negative 28, but multiply to give me negative 60. So I'm going to ignore the x's right now because I know each one's going to have an x. So that just makes it a little confusing. Well, to get 60, and again, I'm going to ignore the negative initially. Well, I could do 60 times 1. I could do 30 times 2. I could do 3 times 20, 4 times 15, 5 times 12. I'll put this over here, 12 times 5. And then 10 times 6. After that, I'm starting to get the numbers crossing back over each other. Well, I'm looking for two numbers that multiply to give me 60. That's what all these are. But I want them to add, where one's positive, one's negative, to give me negative 28. Well, the 30 and the 2 is what works. Now, it doesn't really matter where we put it. I mean, I could put the 30 here or the 30 here. It doesn't really matter on this. So, but I know 30 needs to be negative. So I'll put negative 30 here, and I'm going to put 2x here. But it doesn't really matter. Now I'm going to do some factoring. So if I look at here, only thing in common between these two is x. If I factor up, well, I got 5 in common and also an x in common. Now, I could have also said, oh, x times what equals 5x squared. But once I get one cell, once I even figure out one of these, I can figure out everything else. So here I've got x times 2, 5x times negative 6, and then make sure it works. 2 times negative 6 is negative 12. Okay, that worked. There are my two factors, 5x plus 2 and x minus 6. Okay, question 7. We want to know what the vertex is for this problem. There's two methods on this one as well. First method I'm going to show you is completing the square. To complete the square, first I got to do is get my x's by themselves. So I'm going to subtract 5. Next, I need to have x squared with nothing in front of it. So I'm going to factor out whatever's in front of it. In this case, it's a 3. I'm going to leave a space here. Now, to complete the square, once I get an x squared plus or minus some value, I take half of this number. So half of positive 2 is 1. Square it, I add 1. But when I added 1 here, I didn't add 1 to this side. I added 3 to that side. So I add 3 to this side. Then we have y minus 2 is equal to 3 times. Now I've got this into a perfect square. It's x. Half of this is 1. And then I get y equals 3x plus 1 squared plus 2. So my vertex is at negative 1, positive 2. Remember, we use the opposite for there. That's what makes it equal 0. Now, if you have trouble with completing the square, if you think that's too complicated, here's another method. Take your equation. This is the averaging the intercept kind of idea. It's averaging two equal values. But since I'm not going to try to factor this, it'd be too difficult. So what I'm going to do, in fact, it won't necessarily factor. I'm going to let it equal whatever the y-intercept is. So 5 equals 3x squared plus 6x plus 5. We changed to a dark pen because it's kind of hard to see the pencil. So I just set it equal with 5s. Subtract 5 from both sides. I get 0 equals 3x squared plus 6x. Then I'm going to factor this. In common, we have a 3 and we have an x. Left hand side was x plus 2. If I solve this, I get x equals 0 and x equals negative 2. My vertex is halfway between those two. So halfway between 0 and negative 2 is negative 1. To find my y value, I go back to my original equation. Go all the way back up to here and plug in. So I would have 3 times negative 1 squared plus 6 times negative 1 plus 5. This gives me 3 minus 6 plus 5. So I get negative 3 plus 5. That equals 2. And my answer was B. So we have two different methods for working with that. Okay, problems 8, 9, and 10 all deal with functions. I'm just getting used to function notation. Okay, G of 5. Difference between solving and plugging in. This says use the function g and plug in the number 5. So I'm going to plug in 5 into g. I get the square root of 5 minus 9. This equals the square root of negative 4. And this one, because we're including, there's nothing where it says no solution, no real numbers, or anything else like that. It means we have to worry about complex numbers. Square root of negative is what's going to give you I. So this equals 2i. Okay, for 9, it says a value where f of x equals negative 24. Well, that means I'm solving. See how it says f of x equals negative 24? Well, I'm going to replace negative 24 for f of x up here. So negative 24 equals x squared minus 10x. I want to solve this, so it's 0 equals x squared minus 10x plus 24. And when problems are like this, these ones are usually a little bit easier to factor. To get positive, I have to have signs the same. They're both negative. So minus, minus. Two numbers that multiply to give me 24, but add to give me 10 would be 6 and 4. X minus 6, x minus 4. But I've got to still solve it. So to make this true, either x equals 6 or x equals 4. I find my answers. There's no 4. So my answer was 6. Okay, last one, we want to find g inverse of x. So we're going to be doing undoing g. So now I want to think about how g was built. There's two different ways of doing it. I'm going to show you both ways again. So g of x equals x minus 9. So if I built g, I would have started with x, subtracted 9, then I took the square root. So I'm going to undo that. So I start with x, undo the square root, I square it, undo minus 9, I add 9. So that would be the quickest way of doing it. If you don't feel comfortable with this, in inverse, we exchange x and y. So what I'm going to do is I'm going to call this one's y, that's x. So I'm going to say x equals the square root of y minus 9. Square both sides, I get x squared equals y minus 9. Add 9, I get x squared plus 9. So my inverse was that one.